So last one of the unit, so page 481. This stuff is fairly incredibly straightforward. The most likely place for you to lose marks on today's lesson, like if I was to ask you a question on this, is you're not providing enough detail. So the Carter family is driving from the Yukon for a family vacation. Their journey is represented below on the graph. So take a moment. We always read our axes. That's the most helpful information for us. So we have time of day versus amount of fuel in liters. So their gas tank. Make sense? We're talking about a car trip, road trip here. Their graph of their journey is divided into 8 line segments. So our graph goes down, it plateaus, it goes up, it goes down. There's some patterns here. What's happening between points A and B? So the first portion of our graph, what's going on there? Go ahead, Khalil. Good. They're good. You're totally right. I'm also looking for words like constant. So they're driving at a constant speed, right? We can tell it's a constant speed because that line is at a constant decrease. If they were speeding up and slowing down, it would be more like jagged and varied. So they're driving at a constant rate for how long? Good. So the key things that I would be looking for is this constant rate and the time. I would hope that we all can figure out that they're driving, right? We're talking about a road trip. If you tell me that their gas tank is depleting at a constant rate, like, yes, but what does it actually mean? Let's add a little bit more context to it. What's happening between points B and C? Go ahead, Jacob. Good, so good, right on, not moving. Likely, if you're on a road trip and your car's not moving for 30 minutes, what's happening? You're eating. It's probably lunch or like a break. It's in the Yukon, so maybe they're like leaning over the edge of the mountain and looking at some mountain goats. You never know. Okay, what's happening between points C and D? Good. Right on, refueling. So what's really important between points C and D is like no time is passing and it's jumping up that high. Time is actually passing, let's be honest. Gas tanks don't fill up immediately like that, but our x-axis is in hours. So there probably is like an ever so slight angle to that line, but because it's a big enough, like my spaces in between my ticks on my x-axis are a large enough unit, we don't actually see that angle. But like you have to stand there holding your gas pump for a period of time, right? Not very long, but a period of time. Okay, physics is coming into play. So maybe you've gone that far in physics, maybe you haven't. What is the rate of fuel consumption in liters per hour? So it tells us liters per hour, which is basically telling us we have to go our liters divided by our hours. Per is just our division symbol. So between points D and E, it tells us. So let's just look at our graph. What are the coordinates of point D? Take a second, count it out. So time of day would be your X. So point D, is it actually at 10 or is it a little bit past 10? 10:30? Okay. Sorry, it's hard to see on the screen. So it's at 10:30 and 60 liters. Point E is at 2? Is that right? And is that 25? Okay, so how many hours between 10:30 and 2? 3.5. Good. So our time is 3.5 hours. And then we have our liters is going to be 60 minus 35, which gives us 25 liters. Fuel consumption was liters per hour. So we're going to go 25 divided by 3.5. Oh, I'm sorry. I said it was at 25, didn't I? So divided by. We all should have calculators with us. What is 35 divided by 3.5? What'd you get, Ellie? Good, 10. Same numbers, guys. So we get 10 liters per hour. Which line segment represents the car being refueled for the second time? Good. G and H. Calculate the total time the car is being driven. So they started at 7 a.m. and they went to 1700, which is 5 p.m. How many hours there without breaks is that? 8 hours? 7 hours? Oh my goodness, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 hours for their day, minus something though. So they had 10 hours total, but we got to take away their breaks. They broke for an hour and a half. So what's 10 minus 1.5? 8.5 hours. This is a massive day. If fuel costs 85 cents per liter, this is super cheap. How much does gas cost right now? Good, so just over $1. Fuel's always posted in cents, but just over $1. 85 cents per liter. Calculate the cost of fuel used for the first day of the journey. So in order to do that, what information do we need to find out? Good, we need to first find out our total liters. So to do that, let's look at all of our different segments. So from A to B, how much fuel was used there? Good, 30 liters. B to C, we don't care about. No fuel was used. D to C, we don't care about because that's them filling up. So then we have D to E. How much fuel was used there? We already found that one at 35. Our next one, E to F, is taking a break. So then we have F to G, which is 10, I believe. And then they fill up again, and we have H to I, the very last leg of their journey, add another 10. Yep. Yes, you are assuming that it's constant rate the whole time. So yeah, in this case, it's pretty obvious, but I'd be careful of that. So now we know when we add that up, we get 65, 75, so we get 85 total liters. What do I do with that number? Go ahead, Khalil. But they still had some to start off in their tank, so you have to include that original chunk. Yeah. So 85 total liters. So their cost then in total is your 85 liters Let me write that nicer, sorry. 85 liters times 0.85 dollars per liter. So we convert it to dollars because no one cares about how much money you spend in cents in total in gas, right? That's not very much money. Or that'd be like a lot of cents. It'd be hard to understand. So then we get a total of $72.25. Very cheap day. Because they put it in 24 hours, you should express it in 24 hours. So then it would be 1025, like 1025 is how you would actually write it out. I would accept anything that's like clear to me that you know the time. Okay, turn the page. So these questions, let's just talk through them. So suggest a possible scenario for each of the following graphs. So it's speed versus time. You have to be really careful with speed. What's the units for speed? Or what's possible units for speed, I should say, maybe? Good. It could be kilometers per hour. So we could be talking like about driving. It could be meters per second. You could be running at a constant speed, right? So speed is like another word for velocity. So if I have a plateau for speed, what does that mean? Go ahead, Jasmine. No. Sophia. Good. You're running at a constant rate. So you have to be really careful with speed because it's easy to think that you just stopped, but you haven't. My speed isn't changing. I'm running at a constant rate. So let's say we are talking about running in this first graph. So you'd say like the runner starts off running at a constant speed. What happens if it goes downwards like this second chunk? What's happening there? Yeah, good. They're slowing down. Have they stopped? No. So they're slowing down again at a constant rate, though they're slowing down. So you're steadily getting slower and slower versus, I don't know about you, when I'm running and I decide to slow down, it's like I slow down really fast, right? So they took their time to slow down. Then they again ran at a slower but a constant rate. They sped up, they accelerated, you might say, ran again at a constant rate, and then they constantly slowed down until they stopped moving. Question like this, you are literally going to write out that little story for me. I'm not going to make you write it out right now because I feel like that's a lot of writing and this is pretty simple stuff, but that's the sort of thing that we're looking for, lots of detail. This next graph is a little bit wonky. Could someone take a stab at explaining this story? So this is like story time. What's the story happening here? Go ahead, Khalil. That would work for the first one, because if you kick a ball, it's going to like speed up as it goes up in the air and then, no, because it's a constant speed as it comes back down. So no, that wouldn't work here because it's speed. No, that wouldn't work. So that was a good idea though. I liked it. So again, here it's like I'm running fast, 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 then I'm slowing down. Then I'm running fast, 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 then I'm slowing down. I'm running fast, 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 and then I'm slowing down. Why you would do it this, like interval training maybe? That sort of thing happening here. Okay, let's draw our own story. So the oven temperature when baking a pie. So again, we have time in minutes, and then we have our oven temperature. This context, let's say we're starting with our oven turned off, since we haven't preheated it yet. So what does it look like as the oven's preheating? What type of like line are we drawing? Go ahead, Priscilla. Totally. Diagonal line going up. I don't know about your oven. I'm not going to be super like, I don't know how steep of a line this is going to be. So we have some time takes to preheat your oven. Once it gets to, I think 375, I want to say you bake a pie at, something like that, it should just stay at that constant temperature. So we should have a good chunk of time where it's at a plateau, the same temperature. And then hopefully you remember to turn your oven off, and it should decrease probably a little bit sharper than it warmed up until it goes back down. Actually, is it going to go to 0? No, your house is not at 0. Probably starts like here, right? Like at room temperature. I would let you guys go to 0 though, because that's a hard thing to think about. But truthfully, your house is probably like 20 degrees Celsius, so it starts there. My proportions are wildly off here. But there's that little bit of a context there. Okay, Ben's taking part in a 100-meter sprint. How long does it take to run 100 meters? Did someone just say 10 minutes? No? Okay, I was like, 20 seconds? Like, not very long. So the time here is in seconds. Note that they did that for us, which is good. When you sprint, what do you do with your speed? Like, you're right away as fast as you can. Good. It's a good burst initially, and then you kind of abruptly stop once you're done your sprint. So when you do this one, we're going to have like, you're starting at 0. You're going to go pretty fast for your 20 seconds, and then it is going to have a little bit of an angled decline, right? As you try and stop as quickly as you can. Questions I will give you will have much more of a story than this. They will be like, take a journey. What's happening on your journey? That's it. Crazy difficult stuff. Why is this in grade 10? I don't know. I teach my grade 8s the same scenario. We do very similar questions to this. So that's it for our unit. I don't even think I assigned questions here. Because, I mean, come on. You guys can do this. Number 7 and 8. So there's 2 practice ones for you to do where you're drawing some pictures here. That's it. And then I have a review booklet I'm going to hand out. I will post it to ManageBack because I don't think I actually posted it yet. And then I still need to make the solution key for that.